this computer. So I think recording has started. Therefore, without any further ado, I should go back and share my slides. Sorry, screen. And now you must be seeing my screen. Well, before I start, this is a quick overview of Carlton University, because there are people here who may not be that familiar with the university. We are located in Ottawa. We have a sister university here, University of Ottawa. Carlton is more focused university. Engineering plays a very important role here. And it is the university which has the communications. I guess it is the only university in Canada which has a Bachelor's of Engineering program in communications engineering. And especially telecommunications university distinguishes itself according to this year's one of the rankings, which does the ranking in this subdiscipline level. It ranks number 27 in the world in the area of telecom engineering. So the title for today's presentation is A Novel Haps Vision, or a novel vision for high altitude platform station systems. There is a big overlap between this presentation and the one I made as a Hacettepe University seminar 2 weeks ago. Actually, the reason I am making this presentation is to indeed instigate a discussion afterwards. And people in my own group have seen parts of this presentation several times in different contexts. Very many people contributed to this concept, or the vision, I should say. Once again, I would like to ask everyone to put themselves to mute. Yin, for instance, yourself. Yes, first and foremost, Professor Güneş Kurt, who was a visiting professor at Carlton last year. It was a pleasure to host her. And then many other people from my group. And then Professor Abbas Yongaçoğlu, with whom I was chatting minutes ago, now Professor Emeritus at University of Ottawa. Much of our research in aerial networks in general is done together. As a matter of fact, the thanking list is much longer, and I will return to that in a moment. But especially for people who are joining first time, I just want to give a very quick overview of activities in my group, which are divided into streams. We have this integrated aerial terrestrial network stream. We work on moving base stations on the ground, as well as an agile network architecture, things like relays, mesh network, device to device, and then UAV base stations and UAVs as users, such as cargo drones. That is an important stream, substream. And today's topic, high altitude platform station, has over the last 2 years become increasingly important within my group. In addition to this, we have a team of researchers working on low Earth orbit satellites, LEOs, mega constellations. And with Güneş, we have plans to extend this work, aerial networks, satellite networks, to space networks. It is a hot topic these days to establish a network, for instance, on the moon, as activities in space travel is getting quite a bit of attention, as you know. So this is a big bulk. And then we have physical layer work going on Especially two streams are important, one of them faster than Nyquist signaling, and also millimeter wave massive MIMO. I maybe forgot to highlight there, in particular in connection with NOMA, and then many other emerging technologies and enablers. So we have collaboration with many universities in Turkey. I listed them here according to, in an alphabetic order according to university name. And I am even not sure if the list is complete in any way. What you see is the colleagues, faculty members with whom there is an ongoing collaboration or starting collaboration in the framework of aerial networks. Then there are a number of other faculty members. We are collaborating on other technologies. As a matter of fact, I didn't invite those colleagues because the topic is kind of tangential to them. In particular, Ankara Yıldırım Bayezid University Professor Enver Çavuş. And then collaborations in a variety of topics, including aerial networks, in particular with Iranian universities, but then Tunisia, Saudi Arabia, China, Russia, Jordan, Morocco, US collaborations constitute an important emphasis in my research group and career. And just a parenthetical note, I, over the years, hosted more than 50 visiting scholars at all levels, from PhD student to postdoctoral fellow to visiting professor. That program is on hold due to COVID, but I understand that university is working on a virtual visiting program. Interesting. And also another point is university also has a successful co-tutel program in PhD. A student can have a home university, say in Turkey, Istanbul Technical University example, and then host will be Carlton, and then student satisfies the requirements of both universities and get PhD from both of them. Okay, so here is the agenda. First, I will define high altitude platform station. I guess most of the people here are familiar, but just to make sure that we are all on the same page. And then I present this novel vision. And those of you who are familiar with Haps systems and contemporary research in my group, actually this vision is what we have been working on for the last 2 years. So for insiders, it is not that novel. And this new vision creates many opportunities. I will try to highlight at least some of them, the major ones that I can think of, and then some concluding remarks. So the plan is, after each section of talk, I will just pause for a short while, and then we can have a short discussion, or as long as it continues. But at the end, hopefully, we will have a longer discussion. So please do, jot down your questions as I speak, or discussion items, really not a question, but even disagreement, concerns and issues. I'm very much interested in hearing, problems you envision. It is extremely important to identify research problems so that we can explore them. It would be converted into an opportunity. Well, this is a view graph from a recent paper. Basically, we, in the last few years, started using this word, vertical HetNet. Obviously, HetNet refers to the terrestrial network with various types of access points, small cells, macro cells, as well as cloud RAN, distributed antenna systems, various sorts of access technologies. And we started advocating that this can be extended vertically. And then the term VHetNet comes. I just put 2 recent publications, transaction papers, where we use the word. I'm thinking that as a title of a paper, the first time it really appeared was this December 2019 issue of TWC. And now I'm very happy to see that others are using this term VHetNet. Let us go to the view chart. The terrestrial HetNet is, of course, very familiar. There is a lot of activity in UAV base stations and relays, including in my group, and I actually take some credit there to my group and collaborators to do some early original work. I remember discussing the concept with Professor Abbas, I think 2010-15, but that is now in a way history, in the sense that earlier this year 3GPP endorsed this concept as UXMB. And then there are UAV UEs, in particular cargo drones. We think that this will be a very big concept and possibly transform the retail industry. But today I will not talk about these UAV layers, although it is a very active discussion. And on the very top, obviously, there are satellite networks, especially LEO mega constellations, due to, in particular, the popularity of SpaceX. This is now very mediatic. And then in the middle, there is this Haps network, which is, I think, less understood. And in my view, and this might be something very strong, which has tremendous potential, to the extent that I sometimes feel uneasy when I talk to people and then they don't appreciate the concept, and then, you know, why others don't see it the way I see it, perhaps. But this is actually getting increasingly less of an issue, because now I'm very happy to see that one of my major industrial partners, which is probably the leader in telecom industry, is showing interest. I have been talking about this to them for more than a year now. I have reasons to think that 3GPP soon may start talking about high altitude platform systems very actively. So what does that mean is that for research community, there may be an unprecedented research opportunity in front of us, say for the next 3 to 5 years. And that is really the reason for today's meeting. So my group's playing with the topic started back in 2016, soon after we worked on UAV base stations. The idea came, okay, how about a platform way up for backhauling small cells? I will talk about this later. Basically, in a nutshell, I guess I can say that this is the first paper. Small cell concept has been around for a very long time now, but one important problem in the deployment is that is the backhauling, because fiber penetration is not always very high, especially in older cities and so on. So the idea there is just put your outdoor small cell wherever it is convenient, like a lamppost, and then with an FSO, free space optical link, or your laser really at the small cell shooting to the skies, and on top of those populated areas where small cells are, there would be a platform, and then it will aggregate all these small cell backhauls, and then it will relay that trunk to an Earth gateway. Actually, in that article, we didn't use the term Haps. I guess we were using the term flying platform. I guess networked flying platform, again, an invented term, because I wasn't honestly aware of the Habs concept as much as I do now. It was really an experimentation, but this paper received just in 2 years or 2.5 years, more than 200 citations, and it is citation record is increasing as the Habs concept is becoming more popular. And then there was a silence for a while, but after the long brainstorming starting last summer, and Güneş was part of that along with quite many personnel from my group. I'm indebted to all of them. We started submitting position papers, and here there is a list of 6. These are, I guess, 5 of them are magazine papers, and one of them, this third one, is at Communication Surveys and Tutorials, a vision and framework for Haps networks of the future. We received the first review results quite favorable. This, if it gets published, it will be the most comprehensive Haps paper in the literature, which is like 45 pages. Excuse me. And the earlier magazine papers started being accepted. All of them are in archive. So interestingly, kind of a rather advanced topic, the marriage of Haps networks with reconfigurable smart surfaces. It is a paper to appear in Com magazine, I guess, in 2021. Likewise, another paper, the lead author was Sahabul Alam, high altitude platform station-based, super macro-based station constellations. I will talk about this a lot later today. It also got accepted recently. Actually, it says here conditional acceptance, but it actually condition is removed. It is accepted. And many others. And I would like to very aggressively populate the literature in this area because there is an opportunity. I just feel that maybe in 6 or 8 months, by next summer, we will see so many papers popping up on different aspects of Haps. And as soon as the news arrive that 3GPP is looking into this, the area will be very crowded. Therefore, let us do some original early work. We already laid down the concept papers, but now it is time to support this vision with transactions type of technical papers. Next, what is Haps? Here is a definition from ITU, International Telecommunications Union, and I believe this definition is from year 2000. It is a station on an object at an altitude of 20 to 50 kilometers at a fixed point relative to the Earth. So this is indeed a very important salient feature. Haps either do not move or it has small movements that for all practical purposes from an Earth user viewpoint, it is like stationary. Now here in the view chart that I got from Google Images, there are 3 different realization of Haps. On the right side, you see Google's Loon project, which is operational actually today, limited operations, but it is working. As the name implies, this is really a very large balloon. And then there are projects in which this is realized like a Zeppelin, like a blimp somehow. The most famous project would be, it's an ongoing project for 10 years, a European Thales project. It is called Strotobus. And then another project by Airbus, and it is called Zephyr. As you see, Zephyr is a fixed wing aircraft, so it cannot really stay idle where it is. It makes these figure 8 moves, maybe within a radius of 1 kilometer. But once again, from an Earth observer viewpoint, if you are on the ground and this is 20 kilometers above, it looks like stationary. Now, a very important point is that I call this high altitude platform station like some other people, but very interestingly, ITU calls this in general high altitude pseudo satellite. So from ITU's viewpoint, this is like another type of satellite, but somehow it is a low cost alternative or a complementary structure. And the main issue is coverage, because satellites are good for covering rural and remote areas and so on. So let us move on. This HAPS concept has a very big history. Interestingly, Canada plays a very important role. In 1980, a project started at Communications Research Center. Well, I should say apparently, of course, I came to know these much later. And they used to call it SHARP, Stationary High Altitude Relay Platform. It continued almost a decade. And then in ITU, there is big interest for HAPS networks for at least 25 years, if not more, because there are spectrum allocations for HAPS systems, at least starting at World Radio Conference 1997. And once again, in the most recent World Radio Conference in Sharm el-Sheikh in Egypt, last year, this time, I think up to 600 megahertz of bandwidth was allocated for these networks in millimeter wave bands. And as I mentioned, there are a number of high-profile projects, and the most recent one, and perhaps the one which has a more chance of success, is Hawk 30 project, which is owned by Haps Mobile Company, which is a subsidiary of SoftBank, which is a Japanese operator and telecom holding. And in addition to all these prototypes, working prototypes, there is actually Alphabet's, Google's Loon, that balloon that I have shown a minute ago. It is operational today in different parts of the world, especially like Kenya. So what is the vision? Vision is rural and remote regions, because, I mean, here the issue is this. Since HAPS has a much bigger footprint, because this is at 20 kilometers above the ground level, when the population density is sparse, it is a very good alternative to the terrestrial network. Terrestrial network will be very expensive. And then there are other niche applications like disaster, when the terrestrial network is not operational. So since the footprint is big, the connectivity is thin, but it is for everyone. So HAPS can connect everyone in remote and rural areas. Well, remote is a little bit different, but certainly rural areas. Still, if you divide the rate by the number of people, everyone will have some internet connectivity. And then ITU is, because ITU dedicated lots of spectrum. These are not the cellular spectrum. At least the historic vision was that HAPS might have its own air interface. It is a different orthogonal system. Although I should say that the more recent HAPS projects, they aim at directly connecting to smartphones. Here are two view graphs from a workshop last week, I guess last Tuesday, October 27th, this 6G, what was it called? 6G summit, yeah, 6G summit. And the subtitle of the summit was Connecting the Unconnected, again, rural and remote areas mainly. So you see in this view graph, as a Airbus manager made the presentation, Here on the vertical axis, you see the cost. On the horizontal axis, you see the population density. The message is that in populated areas, you go with the terrestrial network. If population density is very sparse, very low, like northern Canada, satellites is the way to go. But perhaps in remote regions, rural regions, there might be a good case for Haps nodes. This is the sweet spot. And that presenter argued that one Haps is equivalent to 250 macro base stations. And this calculation is not magic. You find the footprint here, divide by the footprint of a typical macro base station, and probably the number would be around that. Here comes the important chart. I am not talking about what I said so far. The biggest problem in front of Haps systems is it is rich history, because this rich history became kind of a historical baggage. As soon as you start talking about Haps, people think about Google Loon. People think about, well, those people who are old enough, CRC's Sharp project. And none of them were a big success. So again, I'm not talking about these things. I am not talking about the most advanced vision that is presented last week. For me, this is an old vision. And I really stress my students, especially, to disassociate yourself from this vision. And especially in your publications, be very cautious in making remarks like disaster. Haps are good for disasters. Haps are good for remote areas. As soon as you say that, people tie you with not so successful Haps history, and that we don't want. And I would like to tell a story here. When I conceived this topic, and even not at the time being familiar with the very rich literature, and I think this was almost 3 years ago, I went to CRC, knowing that in Canada, this is the forefront. I made a presentation. It was in general aerial networks, but I tried to highlight Haps. And then to my great disappointment, CRC people were very critical. The message was, oh, we tried this 30 years ago, 20 years ago, it doesn't work. So increasingly, I understand that my presentation was not properly tuned, and I'm giving the wrong impression that I am revisiting an old story. So therefore, I make this association right away. And again, for my students, in your papers, please just be very cautious about remarks on disaster scenarios and so on. And I would like to open a parenthesis here. My master's, which I started in 1990, was on distributed antenna systems. The credit goes to my supervisor, Alvino Souza. Of course, as a fresh student right after bachelor's degree, I had no idea on these topics. It was Alvino, a visionary systems person whom I respect very much. He gave the topic to me, and this my master's thesis was probably one of the earliest theses in the topic, and the area is fascinating. In a high level of abstraction, idea is this: rather than you have for a terminal, a mobile, you have association with a base station. Let us forget about that association. You just inject your energy, and whichever port, whichever antenna, whichever base station around in the network which picks your signal, and they push the signal into the network, and at a convenient place, some sort of a cell site or a central station, the signals are fused together. So it is an awesome idea. in early days of cellular, really a departure in a very progressive way from the conventional cellular. But, sorry, the DOS concept never picked up the way I hoped for. And the reason was very simple. The presentation often, and I should take the blame as well as a young researcher, we presented this as the next level of an older concept, which was leaky feeder, and which was around at least since 1970s. Basically, this is a coax cable shielded intentionally in a lossy way so that in a tunnel or a mine, that coax acts like an antenna, and the name leaky feeders. And also in cellular networks, dumb amplify and forward repeaters existed for a very long time. If in a highway, for instance, there is a coverage hole, there is a microwave repeater, so on and so forth. So people made this association, and it was a killer for distributed antenna systems. For a very long time, applications were limited to subway underground, subway stations, until around year 2010, China Mobile came very strongly for the CRAN concept, Cloud Radio Access Network, which is really nothing more than our 1990 vision of distributed antenna systems. You can give them new names like coordinated multipoint transmission and reception. And more recently, the 5G cell-free concept is exactly what I said you a minute ago, a 1990 concept that I did my master's on, but which was, I think, not presented successfully. So let me close the parenthesis. The vision is really important, how you present this. Okay, so there is the first point for pausing. It's already half an hour. So if you have any questions or discussion points before I continue with presenting the new vision, I'm very much looking forward to listen you. So feel free to unmute yourself and say what you have in mind.
Hi.
Yes, John.
I just have a quick question, more on the practical side here. I don't know if it's really relevant or not, but it's just a question that is on my mind, so I'm going to express it. It's about the effect of the Earth's rotation around itself on the Habs. Is this an issue? Basically, what I'm asking is, how is the Earth's rotation going to affect the positioning of the Habs? Is this going to be an issue or not?
Yes.
Or
Yes.
do we work under the assumption that they are always going to be at a given point? They're always going to be at the they're always going to have a given footprint, just like the geosatellites, for instance, except the geosatellites, they're actually moving at the same speed as the Earth around the sun. But on top of that, the Earth is also rotating around itself. So
yes,
yeah, so that's the question.
Very good question. Thank you, Jean Daniel. Here, some of the people in the audience have actually are conducting research in this area, so they even know better than I do, but some others are less familiar with the dynamics. So the short answer is a HAPS can be thought as a non-orbiting satellite. So it doesn't orbit. It is not like a geo satellite which orbits. Well, actually all satellites orbit. But if the altitude is adjusted in a very precise manner, there is a calculation for that, precisely 35,576, I guess, kilometers, then the orbit speed coincides with Earth's own rotational speed. So for an observer on the Earth, geo looks like stationary. HAPS is not like that. HAPS should be thought like a balloon. if I just, let us say, leave a helium balloon just 100 meters or 10 meters above the ground, and let us say that it just floats there, the mechanism here is Earth's gravity. So it is really, it is stationary for all practical purposes. So once again, it is not orbiting. However, there is some fine detail, obviously. These are positioned around 20 to 50 kilometers. The ITU's old vision that I am again trying to disassociate myself with, they might be advocating a higher altitude to give a bigger footprint. But as I will talk a little bit more later, in many cases, lower Haps are more interesting at 20 kilometers. And all the current projects, Stratobas, Zephyr, and Loon, they are between 17 to 21 kilometers. This is way above the transatlantic aircraft lines, which are around 10,000 kilometers. And the weather conditions are conducive, apparently. Of course, this is beyond my knowledge. I just read it. There is no snow, rain, and so on in those altitudes, but there can be some wind. So if we are talking about Strotobas, a zeppelin or a balloon, in order to keep it at the same location, if that is desired, some small thrust might be necessary if there is a wind, for instance. And ITU has a definition actually for this fixed point relative to Earth. ITU defines a cylinder in the sky. Now I forgot the dimensions, perhaps radius 800 meters and maybe height less than a kilometer. As long as HAPS moves within that cylinder from ITU's viewpoint, it is a fixed point system. When it is a fixed wing aircraft, of course, it cannot stay at a position, it has to glide, and they do a figure eight movement to keep pretty much its location. So that is my answer, Jean Daniel. Any other questions or discussion points?
Oh, thank you for your answer. If there is any not if there is no any other question, maybe I can ask my another question that has to do with the what do you make of the dichotomy between feathered Haps versus unfeathered Haps? Is this something that might be a thing at this high altitude of 20 to 50
Yes,
kilometers? Or?
thank you. In this historic HAPS vision, there have been many projects, including perhaps as we speak on tethered HAPS platforms. Well, the idea is clear. There is a tether which serves for two purposes. Number one, backhaul, and number two, energy, which makes life much, much easier. Of course, these are, especially energy is one of the biggest issues for HAPS systems. So if there is a tether with which you power the HAPS, that is very good news. However, I'm not talking about that. Again, in my view, that is a historic thing. The ideas I will present cannot be done in the tethered mode. First and foremost, you can't have a 20-kilometer tether. These tethered HAPS are at much lower altitude, like 500 meters, a few hundred meters in many cases. It is a good start. Maybe we can see deployments of that sort. Actually, deployment of that tethered is important in the near future. If there is a, let us say, terrestrial network is not operational, again, disaster scenario, a truck might come and the truck can, with a tether, launch a Haps, and it is a good solution. It can be operational today. It doesn't need 6G, it doesn't need 5G, it doesn't need 4G, it doesn't need 3G. You can put a GSM base station. So these are old ideas. I'm not talking about them, or in my mind, these are just stepping stones towards more advanced ideas. Thank you, Jean Daniel. One final
Thank you.
chance for any other question. Okay, in this case, let us move forward. The novel vision. Now, it is important to observe that people which are advocating Haps today and for the last 25 years, first and foremost, ITU has a very noble goal. And that is what we call today the digital divide and uh, all the consequences around that. It is, of course, everyone wants to prevent that for obvious reasons. Connectivity today is like a utility. It is no less important than electricity and so on. Especially this became apparent in the COVID times. But fast forward 10 years, 15 years, where at the time when education and healthcare will be very heavily dependent on connectivity, everyone should be in. And United Nations has these sustainable development goals. People will most often present Haps by saying that this is a way to fulfill some of these goals. So I am not 100%, 200% on board with this. But the problem is that if there is no successful business case, Haps networks will not work. And this is precisely why previous Haps deployments were either not successful or it didn't find much widespread acceptance. And the very same argument goes to satellite networks. This talk is not about satellite networks, but the very same reason I am a bit skeptical about the upcoming satellite networks. Actually, Starlink is operational now as a early phase one. If you are looking for a charity to connect the next 2 billion people who are unconnected currently, then we are almost talking about a $1 trillion charity. $1 trillion charity doesn't work. What works is that you make a much bigger business case, and then once the business is successful, it works for currently unconnected people as well. That is my emphasis. So how is this new vision different than the conventional ITU vision? In a number of ways. First and foremost, we are not talking about standalone Haps nodes. This is, again, the Google Loons project, disaster scenario, and so on. Because if the terrestrial network doesn't exist, Haps is just one base station mounted on a balloon. But rather, we have an integrated network vision. I would like to highlight that integration with the terrestrial network, the challenges, issues, dynamics are different with integrating Haps network with a satellite network and then integrating all three. It is a big subject, but that is the vision. We call it a vertical HetNet. Second, now I started perhaps repeating myself, I'm not talking about rural and remote alone, but mainly, first and foremost, densely populated areas where the business is, where the money is. And once that is successful, the coverage can easily be extended to rural and remote and all other niche applications. And in this new vision, the goal is not thin connectivity for everyone, but especially if we are looking at Haps in urban areas as a complementary layer to the terrestrial HetNet, users are connected to Haps whenever there is a compelling need. Otherwise, users should remain to be connected to small cells or macro base stations. So whenever there is a need, some users are connected to hubs. For instance, there might be a temporary hotspot in a place where there are not small cells around, and a nearby macro cell, which might be 5 kilometers away, might be already loaded. So it would be very convenient then to connect those 5, 10, 20 users temporarily for high altitude platform station. I should note that the capacity of a HAPS base station is limited. Today, it would be like a few, with a 5G air interface, a few tens of gigabits per second. As I will allude to, it will progressively increase to perhaps terabits per second. Nevertheless, it cannot cover everyone. Footprint is big, and there are many users in the dense area. So only you connect people who need this or devices. And it is not thin connectivity, it might be ultra connectivity. Also, we are not talking about communications anymore, but as I will allude to, computing is an integral part of discussion, edge computing functionalities, and many other novel use cases. Very different than, again, ITU's vision. This last point is also extremely important. It needs some absorption into this literature and discussion. But the way the current discussion goes is that HAPS within ITU is covered at a division other than 3GPP. In ITU, there are two big kind of, what should I say, directorships. One of them is for terrestrial mobile, that is 3GPP domain. The other is satellite domain for broadcast and things of that sort. So currently, HAPS discussion is owned by that community. They think HAPS is a high altitude pseudo satellite. It is the little brother sister of GEO, MEO, LEO, very low Earth orbit, and then eventually HAPS hierarchy. And that discussion, in that discussion, aerospace industry, the people who built these aircrafts play a leading role. But the new vision that I am trying to advocate is just the other way around. And it is top to or bottom to up, bottom up. We start with the small base station, and then there are macro base stations, and then eventually high altitude platform station based super macro base station. It is quite mouthful, but from now on, I will just say SMBS, super macro base station. So now this is the big brother and a natural extension of the terrestrial network. And I'm advocating this for the 3GPP community and industry. And I feel that it is getting some traction. And again, great next 3-5 years to do foundational research in this area. So what should be researched? Immediately, there are a few research areas that come to mind. The first one is, well, these things should be studied from an aerospace viewpoint, and of course that is beyond us. For instance, the Zephyr aircraft I have shown, its record is 28 days continuous operation. If it is in the form of a balloon, it can stay in the order of months. But even if we go with Zephyr, 28 days is short, it should be longer. And then maybe the payload it can carry is still limited. As I will talk about later, we are actually envisioning a small data center in the sky. This might be like several tons of weight. So much better aircraft might be needed, but I will park that discussion there because I don't know much. Another interesting discussion, which is now more relevant, is energy. Currently, all Habs systems are solar powered. I think either entirely solar powered, and I believe Zephyr is an example, 100% solar powered. And Strotobas, for instance, that big Zeppelin might have some other maybe energy source as well. But due to the weight, it is again very costly. If Haps have additional functionalities beyond just a bit of coverage, more energy will be needed. So there is at the moment no good study on the energy budget of Haps systems, and this is an area that waits contribution. So we might take a note, and I am actually writing to myself as a note. So what other energy sources there can be? Now, look at this view chart. I find it so beautiful, although the drawing is, of course, very rough. I found it somewhere deep in internet. This is a chart from 1980, drawn by Communications Research Center people in Canada. This is, well, for people connecting from Turkey, Communications Research Center is like TÜBİTAK Gebze in Turkey. It is a government research center. So they actually operated this Sharp aircraft, as you see, and look, very interesting. It wasn't solar powered. It had no onboard energy source. It is powered by a field of microwave antennas from the ground. So today, this energy remote charging, it is a big idea, of course, but mainly in the framework of smart devices. And of course, the idea goes back to Tesla. But it is implemented in Canada. I find it very exciting. This fairly large platform worked. It is, again, a fixed-wing aircraft, so it has to move. It was moving in circles, and the field of big microwave radiators you see. So today, since we have a much better understanding on these remote powering technologies, in 2030s, this can be a support, not the entire energy, but even a 10%, 20% support will make things much easier. And then nuclear power. Today, some satellites do use some sort of nuclear energy, and I think this is another possibility. And more realistically, perhaps a combination of all three: solar, remote charging, and also the nuclear energy. Let me move on. And then comes a very big topic, and that is the integration. I have a lot to talk about on this, but I'm not sure if I should do it now or a little bit later. But let me start the discussion. If we visualize Haps as a super macro base station on top of populated areas, once again, this would be a third tier in your HetNet architecture: small base station, macro base station, and then super macro base station, which means that all the issues that were concerned to us, and this is still a hot topic in the literature, but it lost momentum. The better work, or the most of the work, was done in the last 10 years, last decade. The integration of small cells and macro cells together. Excuse me. The issue of interference, UE to base station association, radio resource management, routing, spectrum. Should they have orthogonal spectrum or should have the same spectrum? All of this should be carried to a three-layer architecture. actually, if anyone wants to get into this area and then produce a quick publication, which is also relevant, I would pick this as a domain because we know how to do this HetNet layer 2 work and layer 3 work. That should be extended to the 3-tier network. As a matter of fact, there is much more to this, and I will again revisit this later. And due to the following reason, the third tier is, as a matter of fact, might be a little bit different than the first two tiers in the sense that it might belong to a different service provider or an operator. For instance, in Canada, we have the big three operators, wireless operators, TELUS, Rogers, Bell Mobility. And then there might be a third party. It might be Airbus, for instance, which has a fleet of 50, 100 Zeppelin type of super macro base stations, some of them shared by different operators. So we are talking about two different operators are talking to each other. Or if you integrate Habs with satellites, certainly satellites would be different operators, whether it is Telesat or Starlink or Amazon. So in literature, this is called interdomain. I sometimes call this in my group across what was the word? I forgot. Ecosystems, yes, because satellite is a different ecosystem. So this integration issue or interdomain issue is more than I do roaming when I go to US. So I was on Bell Mobility and then I cross the border, it becomes Verizon. It is not like that. It is going to satellite or aerospace domain, which is a different industry. So this interdomain negotiation, management, these are big issues. We have some work that I will highlight, but again, it is a big research area. And I should mention that in 3GPP, this is a very active area in 5G, interdomain dynamics. And then, as I will also allude to in a moment, Haps will rely on quite a bit advanced antenna architectures, whether it is beamforming, millimeter wave, massive MIMO. These topics are also important for satellite, and they will be important in HAPS as well. And free space optical, there is a lot to talk about FSO, that is laser-based communications. This is a great backhauling opportunity for, let us say, small cells, or if HAPS is a super macro base station, once through access it collects traffic, HAPS can be connected to an Earth station or it is tied to an Earth station through free space optical. Likewise, HAPS can be connected to LEOs through free space optical. Especially HAPS to LEO FSO is very convenient because atmosphere is first thin and then no atmosphere as you come close to satellites. As those of you who works on FSOs, and I am here just checking if Eylem is here. Oh, Eylem is here. Eylem is our FSO expert. I'm very happy to collaborate with him. In when there is atmosphere, FSO is a little bit difficult. Anyhow, backhauling might be possible. But let me park that discussion there as well. And then a big issue, security and privacy. I will come to that once again. So if somebody exposes me to HAPS in a lecture in an hour or so, and then ask me, well, go and write the major issues that come to your mind, I assume these would be among the list. So these are very important, and research is going on in my group and with collaborators in these areas. And I should highlight that these are rather obvious, which means that probably many other groups are currently working in these areas. And then there are some less obvious issues that I will highlight next. But let me again pause here and rest a little bit as well. And the floor is once again open for discussion.
Hi, Professor Halim, it's Nasreen. Just for, like you already mentioned, like two companies, Haps Mobile and SoftBank. They are from Japan. And actually, like from last week, I was preparing a paper from their authors. They talk about like how they are sharing the spectrum between Haps and terrestrial networks. And like they had a very nice proposal where they had even like test bed. Like I think they are like equipped. They have like Haps, and they are like measuring signal, and they are like doing some. It's kind of a cognitive radio, having like one spectrum or like one frequency to just terrestrial, and another frequency that is shared between terrestrial and Haps. I will write the name of the paper here. It's really interesting, especially like when you mentioned Haps Mobile and SoftBank. I was checking; it was the same people. They have this paper about spectrum sharing between terrestrial and Haps. I will write it here so anyone can check it.
Thank you very much, Nasreen. A few remarks just for clarity. Actually, Haps Mobile is a subsidiary of SoftBank, so it is the same company. It is like Loon is subsidiary of Alphabet. Second, I think there will be many big players coming into this domain. And when I made a presentation to one of my industrial partners, I ended with a kind of joke. If I can raise $10 million, what shall I bet on? And I think I would bet on a startup on Haps. And then the next question is, if I can convince a big player like Ericsson or Nokia or Samsung or Huawei to have a subsidiary for $1 billion investment, I would suggest Haps as well. I see a very big opportunity there. I had another comment as a follow-up to what you said, Nasreen, but it just skipped my mind, and just leave it there.
Okay, I just sent the paper to everyone in the chat. If anyone wants, just like it's a short paper, but it's really nice, like how they were having like this quantitative results about like the spectrum.
Oh, yes. Actually, the test bed is very important. That was the comment. Now, in research, actually, this is a very important comment. Here we go. We first have concept papers, and we are already many of them out. And then we have to have solid transaction papers, which gives confidence. Because at the end of the day, I can have a concept paper about a base in Mars in 2050 with nice view graphs, so on and so forth. And it might be convincing and everything. But immediately the question is, what are the challenges? How we do this, right? So in my group and with my collaborators, we passed the vision state, because vision is out. It is, and I feel very privileged to work with so many of you. Together, we defined that vision, first and foremost, Güneş and Teslim and Mohammed Hoşholk and Sahabul and so many people. So it is time to come up with concrete, convincing technical results. But it doesn't stay there. The next step is to have a simulation platform. And that is happening as well. Actually, at the very end, hopefully we will have more discussion, but with Professor Tolga, I believe Konukman, the last name, who is in the call now with Güneş at Istanbul Technical University. there is an initiative to have a large-scale simulation platform, not developed overnight, but over time. And who knows, at some point in the coming years, we might be part of an actual building these things, because Carlton has a very successful aerospace engineering program. As many of you know, we might partner with them. Another very important point, since we do not build things, like for instance, if we were talking about antennas, right, electromagnetic research, people would expect eventually you build some prototypes. In my group, prototyping is difficult again, especially with the Haps platform, except for perhaps simulation platform. However, our prototype is basically presenting ideas in 3GPP terminology. So I want to ask anyone in my group, actually, whichever technology you are working on, in particular, given that most our research is supported by industry, you should be very familiar with the 3GPP language. So let me leave that discussion there as well. And one final comment I should have added to this integration part. When it comes to spectrum, for instance, Nesreen, how do you assign the spectrum, cognitive radio, all these topics. Indeed, in 5G discussions, there is a novel construct called IAB. Now, everyone in my group should know what IAB is. If you don't know IAB, it means that you are not following 3GPP closely. IAB is a very important technology or paradigm. It is called integrated access and backhaul. So it refers to, as the name implies, one spectrum for both backhaul and access, especially in the context of small cells, but this very much applies to Haps discussion as well. Okay, so let me stop that discussion there. Very good.
I have a question, just a final one.
Yes, please, Nesreen.
Yeah, just the last question. Like you talked about the FSO and the potential of having like FSO link as a backhaul between Haps and like terrestrial gateway. Now, like if we want to have like a journal paper and it's just analytical like characterization of performance and so on. And now, especially if you have the model of this link, because it's different than the FSO terrestrial, because now you're like 17 or 20 kilometers up on the sky. Like if I have that model, like should I like do like a study on relaying, for example, assume that a Haps it's a relay on the sky, or like assuming that the Hap is actually like just the base station, a macro base station, and covering terrestrial user on the ground? What do you think is like the most promising like use case?
Okay, I have many things to say. The first thing, the most important thing is you write an email to Professor Eylem Erdoğan, who is here now. Eylem, do you want to say hello? If you are...
Hi, Hocam.
Eylem, as many of you would remember, visited Carlton 2019 summer, back in 2016 as well. So Eylem is our in-house expert on FSO. I encourage you to communicate with him. Now, coming back to other questions, 20 thank you very much, Eylem. 20 kilometers is not much for FSO. Nesreen, actually, ISS, the International Space Station, at the moment, as we speak, is connected to many satellites in the space through free space optical links. And do you know how long they are? 5,000 kilometers. The thing is, when there is no atmosphere, it is kind of rather easy. But here, from Haps to ground, of course, at least close to ground, there is thick atmosphere. Things are a little bit challenging. And another remark there is that, especially Haps to Earth Gateway, I would think that there should always be an RF backup as well. So although I say FSO, I mean hybrid FSO RF. Secondly, how to consider hubs. Hubs, even if it is a base station, this is, I want you that we are all on the same page here. Regardless of the functionalities at Haps, whether those functionalities are simple, so it is more like a relay, or functionalities are more advanced, like it is a macro base station, or functionalities are more advanced than any base station you can think of today. That is our vision. That is a data center and a macro base station in the sky. At the end of the day, it has to be connected to the core network. So therefore, the backhaul. So backhaul is always there. The relay, so whether it is a base station or a relay, it is a discussion. If you are thinking about connecting Haps to satellites, for instance, or consider Haps, I will talk about that in a moment, as an interface between satellites and smartphones. It is a kind of a relay, perhaps, but it is not necessarily an analog relay. So a very short answer is relay is, it can be taught as a relay, but relay is giving, the definition of a relay is doing injustice to functionalities that I am talking about, to the extent that this is not a base station even. It is much more than a base station. So I will be very cautious to call Haps a relay, although it can be perceived like that, Nesrin. Is that okay?
Yeah, thank you so much.
Very good, very nice discussion. This is what I wanted. Any other comments? Any other discussion points?
Just have an addition comment regarding the FSO.
By the way, since not everyone knows each other, I guess it is good to introduce yourself very quickly. Safwan.
Yeah, this is Safwan talking. Regarding the FSO, I remember that Cabanina project in British and in UK, they are trying to use FSO.
Safwan, I missed that. Which project?
Cabanina, or I don't know how it's called Cabanina project. It is in United Kingdom. With the collaboration of University of York, they did like a demonstration that FSO link from the ground to the hubs, and they showed that the data can be transmitted, and they demonstrated that and they tested that the transmission rate was 1.25 gigabit seconds. So it was just like a test bed with the FSO link.
Oh, yes, Safwan. Just let me elaborate on that. York University in the world, in academia, has the most advanced Haps testbed and research historically. They started before everyone that I am aware of. Haps research there goes back to 20 years, and it is Professor, now the chair is Professor David Grace, as many of you would be aware of. It is a multidisciplinary project that they have a lot of emphasis on Earth observation, ozone observation, and so on, in addition to connectivity. I give credit to them. I am in touch with them. But big remark, we are not talking about what they are talking about. I really want everyone to understand this. We disassociate ourselves from literature. So this is kind of an absurd remark. Certainly, we have to rely on literature, but vision is much ahead of that historic vision. So David Grace is a world leader in this area, and I'm very happy to see they have the testbed and gigabits per second is available today. But make sure that you do not limit your thinking with whatever is in the literature. And I acknowledge that York University's work is the leading edge in the literature. Kudos to them. Any other comments, points?
Yeah, I have a question. This is Azaz. I want to ask you about Haps, like if they can be used for long-haul transport networks, wireless or optical.
Yes, very nice and interesting question. This is coming from a leading satellite expert, not accidentally, Dr. Aizaz Chowdhury. Your question needs explanation where you are coming from, Aizaz, and that is one big advantage of LEO mega constellations is that long haul latency is lower than a terrestrial network. So let us take a long haul link, say from Toronto to Hong Kong, for instance. This is an example we used in a recent paper with Aizaz. If it is terrestrial network, of course, it goes from fiber cables, but there are two issues. One, there is no straight line between Toronto and Hong Kong or any other 2 points. It goes through so many routers and under the ocean, whatever, right? So it might be actually twice as long as the straight line. Furthermore, the speed of light in fiber is about 2/3 of the speed of light in vacuum, which means that in vacuum, speed of light is 50% faster. So it has been shown in the literature, and Aizaz wrote a few papers recently. One of them is already out. A second one I think will be submitted maybe today. In those works, we have shown that what is called RTT, return trip time, can be as low as 50% of those long hauls on the ground. And this has, in some applications, very important consequences. One of them is the stock market. You have to make bids very quickly. Those people, like people in Hong Kong, would be ready to invest billions of dollars to have instantaneous access to the New York stock market. It sounds like a joke, but it is a reality. There was a movie about this a number of years ago. I don't know if anyone watched that. I forgot even the name. Now, the question is whether Haps, is it possible? Well, difficult due to two reasons. Number one, Haps will, or the periphery of the Earth will be populated by Haps systems in a progressive way. I don't envision necessarily in the next 10 years 20, 30,000 Haps so that you have a very direct link. This will take a while. It can happen, but it will take a while. And secondly, this maybe we should write another paper, Aizaz. I don't know the speed of light at 20 kilometers. Atmosphere is much thinner, so it will be faster than that on the ground, but I don't know precisely how it is. So at the moment, I don't think Haps networks will be able to compete with LEO mega constellations, but this might be a very interesting discussion item. I am just taking a note of that for future, and you might well look into this. Thank you.
Thank you.
Any other questions before we move forward? Okay, so let us move forward. Let us see. Okay, now new opportunities. Well, Leo mega constellations are very big. You know, that goes without saying. And I am a big believer in Leos. This is a disruptive technology. And sometimes when I talk very passionately about Haps, I feel that some people in my research group working on satellite networks feel, what should I say, maybe a little bit disturbed that their area is not as hot. No, satellite mega constellations, as a matter of fact, have more problems, research challenges. Therefore, if anything, there is perhaps even more opportunity to make groundbreaking contributions in the framework of networking. Networking is much easy in Haps because they stay there, right, for obvious reasons. Leos are very important and very popular because of Starlink once again, but they have problems. Again, problem is not bad. Problem is good for us. It is research. But in the context of this discussion, there are two major issues. One of them, the upcoming mega constellations, starting first and foremost with Starlink, it is fixed wireless. This is very important. It is not mobile. It is fixed wireless. You take a, is this here? Yeah, maybe I just show the second slide as well. You purchase a dish, you put it on the roof of your home. It is, I guess, $500 or $600 US. You can buy it today. And then subscription is another $100 US. It is working, it is operating, but it is not to your smartphone. Why? Link budget is not favorable. Still, these are far away. Now, a very important remark, again, especially students, I want you to understand this in and out. Link budget and coverage for that purpose is a function of rate. At the end of the day, whatever application you have, whether it is texting like SMS or an augmented reality goggle which needs gigabits per second connectivity, that application requires an EB over and not. Or just to work it from the other way around, there is a quality of service or quality of experience target. It is a very complicated discussion, but somehow that user feeling can be mapped to a certain frame error rate and back to some bit error rate and eventually some target EB over and not. So you need, let us say, 4 dB SNR. And EB is, what is EB? And note that and not, we don't have control on that. That's the Boltzmann constant time times the ambient temperature in Kelvin, probably times the noise figure. But on the numerator, we have control. EB is received power divided by rate. So for a given received power, as the rate increase, EB over and not, SNR will go down. So if you move from SMS to video streaming, let us say 1,000 times rate increase, or 10,000 times or 100,000 times, if you go to maybe some augmented reality and so on, suddenly you have a shortage in your link budget, 30 dB or 50 dB, big numbers. In short, Leos today might be okay with for sending signals to your smartphone, but even today it is difficult if it is video streaming, even conversation, real time is difficult. In any event, it is a very active area, and in the near future, I believe Leos will be able to reach smartphones directly without a rooftop antenna, but a big but there, it is a moving target. So at the moment, it can give web browsing our interest would move to, again, high-speed video streaming, 4K video, and then to all these goggles and XR, so on and so forth. So it's always behind. But Haps, direct connectivity from Haps to user terminal is possible. And the second, just let me actually finish, and then you can ask your questions when I pause. The second point is there is a set of technical challenges, and those are related to orbiting. Since satellites orbit, I don't want to get into too much into that. Many people in this call are actively working on those, from handoffs to routing to addressing. These are big challenges, control channel and everything for the user. But if the signal is coming from Haps, it is stationary. So the issue is, with LEOs, there is a lot of moving parts, and Haps bring stability to this discussion. And I will just take the question. I don't know who was that. I'm very sorry, but let me cover this slide and I'll take the question. So here is my proposal. Again, I am absolutely not against LEOs. When Starlink, if things unfold the way they envision, by 2027, when they deploy their 12,000 satellites, and maybe in 2030s, their 42,000 satellites, this will be the most fascinating infrastructure that humanity has ever built. I am extremely excited about LEO mega constellations, and therefore I work in that area. What I am saying is the following. At least in the beginning, LEOs are like the old vision of Haps networks. They are targeting these remote and rural and ships and that kind of use cases. They don't target populated areas because currently they cannot compete with the terrestrial operators because of the technical difficulties I mentioned. Currently, if I have my smartphone is working, I'm on a reasonable plan with Bell Mobility, let us say, why should I pay $500 and erect a dish? And I forgot actually to say, this dish has a motor. It is not like your satellite TV. It is actually rotating because LEOs, they born and they die in about, I don't know, 6 minutes. So the dish is literally moving. It is, I don't know, for instance, how that will work in Canada in harsh weather conditions. Probably it works, but the bottom line is there are issues. It is difficult to compete with the operators. And if you don't compete with the operators, you are in a more smaller market. It is in a fixed wireless market. What I am suggesting is this. Since this big investment is being made, and the original estimate of Starlink was $10 billion, but I think with all the extensions, the actual number will be tens of billions of dollars if the number goes to 12,000 LEOs. Why don't you complement that progressively? This is very important, in a scaling manner with some Haps stations. I'm not talking about putting 12,000 Haps. And some of you, sorry, Safwan, is it you who is not on mute? Just please let us put ourselves on mute. Just invest a little bit and put, let us say, 100 Haps on 100 megacities in the world. Each megacity is 10 million people. 100 of them, suddenly with an additional investment, you reach another billion customers with your Starlink and Cooper and so on. And moreover, these users are rich. It is not your remote communities where things have to be subsidized in most cases. Moreover, as we will discuss, this connectivity in smart cities and so on will create many other business opportunities. And it is a small investment. If you want, start with a pilot project in Istanbul or in Toronto, GTA area, and then progressively increase. So I am thinking that this is such a golden opportunity for satellite networks. And I hope that our group will write a new vision paper in this area, because although we have highlighted a few issues, I think it is not there as a paper. And I already commissioned our new postdoctoral fellow in the group, Animesh. Animesh will be the lead author in developing a paper, a vision paper, as well, maybe a working title, a savior for the satellite industry. Again, currently satellite industry's goal is breaking even. And this new vision might make satellite companies to become global operators, including all the metro and urban areas. And it is a multi-trillion-dollar business, to say the least. So although it is not my section endpoint, there was I guess, a quick question. So let me pause and take that question.
Oh, yeah. Sorry, I think I tried to log my question too early. I should have waited for this slide, because you actually answered it in this slide. Basically, I was trying to, I wanted to point to the fact that maybe it would then be a good idea to have the Haps served in between the LEOs and our smartphones, for instance.
Yeah,
and that is right. Pretty much it's covered in this slide.
That is right. So thank you, Jean Daniel. That is the vision. I should also highlight that this Haps as an interface makes more sense in the urban areas, because if you start putting Haps in rural areas, you will need many of them, because population density is very low in those cases. And I think the golden opportunity is in urban areas. So my thinking is this, at least in the near future, like 2030 scenario, near future in my mind is really 2030. If you are in rural and remote, still you may need to connect to satellites. And at that point, perhaps satellites can connect to user devices, but with thin connectivity due to the link budget discussions I made. But in urban areas, satellites can reach the end user device, whether it is a smartphone or an XR device, through an interface, which would be Haps. We will discuss this more, but let me continue. Next, Haps as a super macro base station. I already mentioned this quite a bit. This is highlighted in a paper accepted literally 10 days ago, and it will appear at some point. I mean, at some point, not very soon, due to the lineup, the queue in the magazines, but it is in archive already. The idea is will be a little bit repeat, but here is the discussion. You have a small base station, a macro base station. As you see, they become bigger and bigger radius. And then I have naturally super macro base station. In some way, this is like a tower at 20 kilometers. So it is a macro tower, but maybe 50 kilometers, 80 kilometers. But then this is a tower at 20 kilometers. And obviously, it has a much bigger footprint. When you think it in that way, it is very evolutionary. And being evolutionary is good because it is low risk. When I, in a discussion, says that I have a revolutionary idea, forget about everything you know. People become very nervous, especially people in the industry. So what are you talking about? $1 trillion investment already made over decades. Are you talking about ripping that out? It won't work. So this is evolutionary, big good news, yet it is disruptive. There are extremely few examples which are evolutionary yet disruptive, and I think Habs is in that category. They can be owned or, again, easy extension. Anyhow, so it is part of the 3GPP ecosystem. Next question, how should the footprint, how big the footprint be? Again, I really would like to ask everyone to mute, including Shishi, perhaps yourself as well, if you are not. The answer is, why are you trying to put a Haps space station? This is the very old question. One of the most fundamental questions anyone who has taken my 5608 wireless course, much of the course revolves around this point. When and why do we put a base station? Fundamentally, canonically, it can be for two reasons, either for capacity or for coverage, right? Based on the population density. If you want coverage, so if you are really thinking Haps as a pseudo satellite, as a low cost alternative, at least in some places, then you would want this very high. This is akin to ITU vision. And in ITU documents, they suggest that they actually cheer the radius can be as big as 500 kilometers. This is almost comparable to some LEO satellites today as a coverage area. If that's the case, you might cover an area of almost 1 million kilometers, a good chunk of perhaps Ontario. But how many users are there? Divide your capacity among millions and millions of users, then we are going back to this thin connectivity. That is not what we want in the new vision. I want capacity. Therefore, I want to bring this as low as possible. My understanding is that due to weather conditions, it is difficult to bring it below 20 kilometers. And there with directional antennas, for example, if you make the radius 8 kilometers, then the area will be 200 kilometers square, just an order or an order and a half bigger than your macro base station. And as you see, the two deployment possibilities, there are orders of magnitude difference. And then how about frequency bands? Well, this is a big question. And this question has two angles. One of them is, if you are trying to reach indoor users, there will be additional stress in the link budget, and because of outdoor to indoor loss. Therefore, probably you should go for below 6 gigahertz. Hubs seems to be very ideal, especially for outdoor connectivity. Not only that link budget is further favorable, but due to this favorable link budget, you can use millimeter wave, and already the bands that are assigned by ITU are in the millimeter wave. So with line of sight, so you know, you might be thinking, oh my goodness, 20 kilometers, really does the link budget work? Yes, it works, because path loss exponent is 2, not 4, and then shadowing is either not there or it is very mild. So in my view, although this should be substantiated with a more rigorous analysis, you can reach up to terahertz band if we think that terahertz starts at 100 gigahertz. And also opportunistically and especially backhauling. Backhauling not only Habs, but backhauling small cells, FSO can be used as well. And then, especially in outdoors, you have a lot of bandwidth in the order of several gigahertz. With antenna architectures, you can reach actually terabits per second links in 2030s. This is what I am thinking of. And then much of these issues are already answered, but if you are still wondering, you know, the metro areas that are already macros, there are very many small cells. Do you really need another level of macro cell, super macro base station? The answer is yes. And the answer goes like this. If you can cover the entire city, I'm not talking about downtown, but if you take Istanbul or GTA, we are talking about the city has a radius of 50 kilometers, if not, well, yeah, with all the suburban areas and communities. So you can't really cover all of them with small cells. You certainly need macro base stations, first and foremost, to facilitate mobility, right? So macros constitute a safety net on top of small cells, and super macro base station is another safety net on top of macro base stations. So there is no coverage hole in this new architecture. By the way, when I say coverage hole, that is a function of rate. So I'm not talking about SMS coverage hole. You can have SMS pretty much everywhere, but I'm talking about coverage hole for your XR device. And an interesting discussion there, since the bandwidth, the connectivity through Habs is much more expensive than the connectivity of a macro base station, because whether it is tens of gigabits per second in the near future, or terabits per second in 2030, or tens of terabits per second towards 2040, the population and the need here is much more. Therefore, you cannot indiscriminately connect everyone to your Habs base station. As such, there might be some differentiated pricing. So if some users, for instance, in the example of Istanbul, if you are in Çamlıca Park and somehow there is no macro base station, but you, in your picnic, you want to do 3D gaming and so on and so forth, you want 300 megabits per second connectivity with your buddies in that picnic area, and then you are ready to pay for that session just $20, well, I can give you that connectivity through Habs. This is the temporary hotspot situation. Another one is IoT. There will be millions and millions of devices in these populated areas, meters and everything, very conducive to cover all of them in one shot, outdoor ones, and then backhauling for small cells, but then many other opportunities, as I will highlight next. So this multi-purpose Habs, and just take me, it will rely very much on antenna architectures. As this is shown, this is a view graph in Sahabul's upcoming magazine paper. You need the wide beam antennas for coverage. You need other beams for hotspots, some beams for three-dimensional 3D highways, for aerial highways, for drones, so on and so forth. So massive MIMO, millimeter wave, antenna beam forming, these are extremely important topics. I believe some people here, I'm seeing Professor Berna Özbek, I believe she and Güneş Hoca, they are working in this area. Berna Hocam, merhaba, are you there?
Yeah.
Okay, well.
Hi everybody.
Hello,
Thank you
hello.
for this very delightful talk, first of all.
We are looking forward to results from you and Güneş on antenna technologies. And there is also Sahabul in my group is also working in this area. Well, thank you again, Berna Hoca, for joining us today. So let me move on. I started getting tired and I have an hour and a half lecture in just very shortly. So another use case which we discussed, this is from the now well-cited paper from a number of years ago. Your small cells are backhauled to Haps platforms, and then they are backhauled to an Earth gateway. Megacity is a big topic in my mind, and I call them smart megacities. These are the metropolitan areas with population 10 million or more. as we move forward. There are very many of them, many of them in especially Africa, an overlooked market, and in Asia, where the population is still growing. And you need advanced technologies, obviously. When I think of smart cities, I have three enablers in mind. One of them is, of course, a very dense network of sensors of every type. And then IoT is the buzzword. You will need certainly AI to maneuver in this very sophisticated setting, but you need robust connectivity everywhere. And here the city is not downtown with all the suburban satellite towns. You need, in my view, a super macro base station. Let me move on. Another example that I am a big believer is the intelligent transportation systems. Just at the interest of time, I started going a little bit quick. Here, again, it's a big ecosystem by itself. I guess I read that by 2040 it will be maybe or 2050, $10 trillion industry by itself. You know the storyline there. You need a robust, very robust connectivity, not only in downtown areas but everywhere. And it becomes increasingly difficult if you are, well, expensive if you are outside the metro areas, the same storyline. A prime example is this Trans-Canada Highway from Pacific to Atlantic. It is 5,500 kilometers, and 90% or maybe 95%, actually, if I make a thick line of 50 kilometers around this highway, probably 98% of Canada's population is around this highway, all the big cities. Excuse me. So I am thinking of a linear mega constellation to facilitate this this paradigm, and the height of the Habs nodes would depend on the population density. So if you are on top of Regina, for instance, this area, which is very lightly populated, your Habs can be at 50 kilometers. But then if you are around Toronto area here, even 20 kilometers, which is kind of the lower limit, or 17 kilometers is not good. Here you will have maybe 5 Habs, a Habs cluster, as I will allude to. So it is a multi-layer Habs linear mega constellation, and I believe it will create many opportunities. And once again, this itself might be a vision paper. This aerial highways, I already mentioned. We have a nice paper from Nesreen, and Güneş drafted a follow-up paper which will be submitted to a special issue of IEEE Vehicular Technology magazine very shortly. So I don't want to spend too much time, but the 3D aerial highways is a big topic by itself. We also have technical papers in this area, and Nesreen is leading the efforts in my group. So an example is, let us take Greater Toronto area. Just next to the city, there is a big warehouse, Amazon warehouse, and it will have some sort of a small airport next to it, with thousands of cargo UAVs are launched, giving a city of 10 million people in a radius of 50 kilometers. These aerial highways, it is showing one avenue, but it will be multi-layer, like small streets and big avenues. And furthermore, these highways are very much congestion and weather conditions dependent, based on winds and rain. They are very dynamic. Anyhow, how can I give service to these cargo drones? Well, immediate candidate is a dedicated terrestrial network where antennas are shooting upwards. But then from cargo, this cargo drone from the Amazon warehouse to a destination 50 kilometers away will have very many, at least 10 handoffs. If I connect them, all of them through a Haps, maybe a dedicated Haps, a Haps only for highways. It doesn't have and it doesn't need any handoffs. It is a handoffs-free connectivity, and these will require some navigational data and so on. There will be platooning, all those stuff in ITS paradigm, and they can be handled by Haps. And I will be coming to this computing and caching point in a second, but this is a big story by itself. Another view graph from Günesh's upcoming paper. We have to also produce technical papers in this area. Here comes another extremely interesting use case, and this is Shishi's work. Shishi is with us today as well. And in my view, this is one of the very high priority work items. And basically, the storyline goes like that. This is in the context of caching, edge computing, I'm sorry. And this can be motivated by terrestrial highways or aerial highways. Here, this view graph from Shishi is for terrestrial highways. So you know the storyline, many vehicles, autonomous and connected vehicles. So anyhow, these vehicles will generate a lot of data two-way, or they will need data. Some of them are just about that vehicle for infotainment systems. You know, people are watching video, holography, and things of that sort. But then a lot of data generated in this vehicle, especially through sensors, road conditions, all that stuff has relevance to surrounding vehicles as well. So it is some sort of what Shishi calls common data. Now, it will be very appropriate to push that common data, or at least part of that, to Haps, which sees a 20 kilometer or 50 kilometer highway, other than pushing that to a roadside unit, because roadside unit has a very small coverage area. If everyone pushes their common data to its own roadside unit, that will result in big traffic in the core network or in this sideway network. That can be eliminated through Haps networks. Shishi is developing a transactions paper. Actually, she has some work just waiting an issue accepted to Internet of Things journal. Now we are extending, we are building on that within the Haps framework. So here comes a very interesting discussion. Shishi, you should elaborate on that in your papers. Now, conventionally, we used to have an access network, wireless access network, which I am not showing here. And then we have the core network. And in the last 10 years, two paradigms, or this, same paradigm, a refined version emerged: edge computing and also fog computing. Generally, so what does that mean? Well, basically, some of the functionalities like computing, offloading, caching, and also analytics, if it is performed at the core, which might be too far away the data center, it is better to do it at the edge. And often in this context, edge would be macro base station. These functionalities, again, whether computational offloading, caching, or analytics, it can be closer to the user in some applications, and that close would be perhaps a small base station. So what we are saying is, let us put a new layer here. I think this will be a very important contribution to the literature, And I couldn't find a new name or a good name, so it is an interim name. I call it fog computing, edge computing, border computing. And that is associated with Haps networks. In another way, rather than control and data plane separation, we are further separate or distinguishing the data plane into two, common data and individual data. And we are pushing this common data, which has relevance to a neighborhood, whether in the air or on the ground, to Haps. This individual data is pushed to edge or fog, but common data pushed to Haps. I think there is a great opportunity to have a transactions paper in this domain as well. Another very interesting discussion, which is the domain of Hongzhou, but currently Hongzhou is taking courses, so the research is a little bit on hold. And I'm not sure if Hongzhou is with us today. Actually, he is with us. And that is the following. It goes without saying that localization, navigation, positioning is very important. We often refer to this as GNSS, Global Navigation Satellite Systems. And in North America, it is the GPS system. And that is facilitated through MEOS, Medium Earth Orbit satellites. Since LEOs are coming very strong, these are the LEOs and MEOS, there is an interest in the contemporary literature to do better navigation, location, and positioning through LEOs, and that is very true. Now, what we are saying is that we can do this even better with Haps nodes. So a number of scenarios are possible. Either a number of LEOs might be supported with the Haps, and here we are thinking that Haps will have atomic clocks. So as you see, going back to Nesrin's earlier question, relay, is this a relay? Well, you know, at a very high level abstraction, you can call it a relay, but I am talking already about putting an atomic clock there. I am putting nuclear power there. This is not only not a relay, this is not a base station. It is much more. It is a big animal in the sky. So please let us be very careful in using these old terms, which might again this issue of the curse of historic richness. Or in a big city like GTA, Greater Toronto Area, if I have a couple of Haps nodes, they might collectively result in localization, navigation, positioning. And in big cities, for all kind of reasons, from surveillance to whatever, having centimeter level surveillance and also imaging in the order of 10 centimeter resolution is big. So it is a big area in my mind. Unfortunately, I'm just talking about this and people are very interested. I'm very worried that someone else will come up with a paper. I think we should very quickly have a position paper in this area with some quick calculations, and perhaps Hongzhou can continue later with more technical papers next summer once he is done with his coursework and PhD comprehensive exam. And then another big story, the marriage of Haps nodes with reconfigurable smart surfaces. This is a paper also coming up in Communications magazine. One important point here is that smart surfaces, Haps are big. We are not talking about small animals. This is a big animal. Actually, this is like a big building, big Zeppelin. It has a lot of real estate that is good for energy harvesting from sun, but good for other reasons, for maybe smart surfaces. So with Safwan, we explored this concept to some extent. And Safwan, if you are here, please be prepared to tell a little bit about what you are doing maybe at the very end, because Safwan has already a short paper in archive on the link budget analysis, and a full paper is in the works. Just coming to an end very quickly. Another interesting point is when you have Haps nodes, so just let me go to maybe another picture to, let us motivate it from this picture. Imagine this is on top of a downtown or city core, which has a radius of 10 meters, something like that. When you are 20 kilometers above, all links are pretty much equidistant, or the distance ratio is 1 to 1.5, or something. So actually much less than that, 1 to 1.2, something of that sort. And then there is no shadowing pretty much, and the path loss exponent is 2, which means that path loss difference between this user here and that user there is maybe a few dBs. And this is very different than our conventional CDFs or complementary CDFs for signal to noise ratio. So in general, in a macro cell setting, the difference between near users and far users might be easily 60 dB, if not more. But here it is much less, maybe 10 dB, or most of them couple of dB. So near-far effect is gone. Then what does this mean? Power control, not necessary, or it is a much less of a concern. How about adaptive modulation and coding, CQI reporting? And then if I put aside multipath fading, which might also be mild in outdoor line of sight environments, maybe there is no need for channel aware scheduling. I can just do blind scheduling, and then no concern for fairness, so on and so forth. All these topics are waiting for us to explore. And then another topic which we discussed is a little bit this inter-domain inter-networking, whichever term you use. And you would certainly rely on AI and ML for control and management. This is an extremely important topic as the network getting sophisticated more and more with multiple layers, Haps and satellites. Controlling this network becomes a nightmare if you want to do it in the old way. So originally, Tesnim from my group submitted a paper. It is under review in Wireless Communications magazine, and more recently, Mohammed Hoshholk with Amin Farajzadeh are working on extending this area. And in particular, in this paper, we defined a new term, self-evolving network, rather than self-organizing network. Our thinking is that self-organizing network captures the evolution happening within a network, but once we have a network of networks, terrestrial is a network, Haps is a network, satellite is a separate network owned by separate entities. So across network, you need a new way of looking at this, and we call this self-evolving network. Another quick discussion is on security. This is a big topic. I have a collaboration with a colleague in Russia. I'm not sure if maybe I forgot to invite him, a leading expert in that area. And I'm just checking the list. He doesn't seem to be here. Well, there is a lot to say here, but at the interest of time, the issue is this. If we are worried about link security in LTE systems and 5G, think about the security when we have UXMB, the upcoming UAV base stations, because the UAV can much easily be compromised in comparison to a fixed base station. And to make it more complicated, the backhaul is also wireless, unlike the macro base station, because once the signal reaches macro, you think that this is now kind of hardwired to the core network, so it is difficult to tap and compromise. Now take it to the next level. As a Habs-based super macro base station on top of Istanbul, overseeing 20 million people and 100 million devices of various sort. Imagine the consequences if that is compromised. So network security is at an unprecedented level now, and a lot of work is necessary there. Güneş has started scratching this area, and there are some good work already under, I guess, review. By the way, at least from my group, all our work in this area is available at my website. URL is given at the end. So I'm coming to an end. Concluding remarks. Unfortunately, there will not be too much time for discussion because of my upcoming lecture. But anyhow, as promised, let me stop and let me take some questions. And in particular, people who didn't ask questions, or not question really, who didn't make comments, I would like to hear from everyone. No need to be shy or anything. It is a rather small group, and we are learning from each other's background and experience. So I'm muting myself for the first comment question. It seems everyone is getting tired. So if anyone has any comment, I'll be more than happy to take that.
Professor Halim, this is Animesh.
Yes, Animesh, please.
I have a comment rather than a question. My comment is regarding bringing forward your MSc thesis work. There's a work related nowadays going on called cell-free massive MIMO. So where like there is no concept of macro cell or small cells. Instead of that, they have a very distributed fashion, access points, and users are the users are allowed to access multiple base stations at the same time. So I feel that Haps and cell-free massive MIMO, they are very good, like complement to each other, because all the access point they can at some point they have to backhaul their data, or to send like some centralized processing unit, and then to the core network. So I think here Haps can be very useful, not only to backhaul the network, but also to provide the large capacity, because the concept of cell-free massive MIMO came to increase the capacity, where the region which is very have less coverage, not coverage, like the edge users where they have a little less capacity. So in that respect, I would say that Haps has a good potential to to complement or use along with cell-free massive MIMO.
Very true, Animesh. Impressing comment. Going back to cell-free, as I see here, I see that indeed an extension of not my, but distributed antenna ideas from 30 years ago. As they say, there is really nothing new under the sun. Pretty much everything is a new look of an existing subject. Actually, in our group, we already started looking at this because your observation is absolutely correct. And I am trying to remember who is looking at this. Can anyone unmute and tell who is looking at cell-free? Was it Omid? I am not sure.
Yes, Professor Halim, I'm looking for, but it's more about backhauling of the signals from UX node Bs towards the Habs.
Yes, so here is a great opportunity. Why don't Animesh and Omid after this meeting sometime, not today, whenever convenient, you have a discussion. Omid has already quite advanced in cell-free, but all these topics, it is not one paper, not one contribution. In cell-free, there are many papers, and we can have cell-free within this context and with many papers. I encourage you to talk. And another special case, Animesh, look at these drones again, moving 50 kilometers from warehouse to a backyard of a home. This is again a very good example of cell-free. You just don't talk to many base stations, so you just transmit. So cell-free can come in a number of variable, what should I say, colors. And let us explore this. This is an awesome, good idea. That is what I can say.
Yeah, I think so. It is a good area to explore with Haps.
Thank you, Animesh. Any other comment?
I have another question. In Haps, like when can be used, or maybe random access by users. So to like there is a limitation of number of users can access Haps. If Haps is a super, like it can be used as a base station. So like I'm thinking like this is why my one question, it might be lead to another. So the question is like like in massive MIMO we have a problem of pilot contamination. So because of that, we cannot grow the number of users to be served. So similarly, this can be also, or a similar problem can be also appear for Haps if it is being used as a base station because of limited number of pilots. So like I haven't have a very full thought on it, but I'm just like thinking this could be a problem.
Very true indeed. And I think Omid, I think you, right? We started thinking on that.
Yes, that's me.
So, well, anyhow, I will let you to speak for a moment.
Okay, yeah, that's a problem, Animesh, but it can be solved maybe by defining a radius for footprint of every Habs so that it's not full coverage and they will have like overlapped cells. In that case, it's scalable for many users.
Okay.
I am actually thinking that although I also took a note that the pilot contamination in the massive MIMO, distributed massive MIMO kind of interpretation, we have to look into this carefully. But just let me try to go here. I am thinking that in these smart mega cities, probably there will be a number of Haps eventually, not tomorrow. So IoT, again, is a very big thing. These are very thin connections by themselves, meter reading. But if there are millions and tens of millions of them, it is a big load. One might put, maybe even at a high altitude, at 50 kilometers, just for IoT, just for meter reading and application. And then for this temporary hotspots, one might have Haps closer and with antenna architectures. If I actually go back to this picture, yeah, here, we may want to create, and I did a calculation, in order to have a hotspot of radius 100 meters, I hope I am not remembering incorrectly, you need an antenna beam of width half a degree. This is something interesting to Berna Hoca as well. So in those cases, pilot contamination is less of an issue. You have a pencil beam targeting a very small area. But in some other scenarios, yes, pilot contamination is important, and it is important to identify these issues because these are research topics for us before anyone else. Thank you, Animesh. Any other comment?
Yeah, regarding IoT, so IoT has a problem because IoT also can have a random access, but the problem is with the preambles. So they are limited by the number of preambles. So it is almost like it's not exactly the palette contamination, but we cannot assign the same preamble to the other IoT devices. So I think we have to also think about in this respect, like how, like it's a research topic to go and see how we can increase or give access to the IoT devices.
Very true, very true. Here, of course, IoT access will be different than, it will not be with preambles, I assume. That is the LTE way of doing things. It is protocol heavy and, you know, this, I don't know if you have ever worked with Zadov-2 sequences and so on. The numbers are limited, CDMA approach in the random access channel. So this itself is actually a very big question. I actually took a note. Is there a multiple access scheme to facilitate 100 million connections? You know, this is not MMTC, massive machine type communications, but you name it, it is much more than massive. So if I have a dedicated Haps with, you know, a gigahertz bandwidth or half a gigahertz bandwidth and data rates in the order of several tens of gigabits per second, what should be the multiple access scheme to facilitate this connectivity that it sees the IoT devices? I think it is an awesome, interesting research topic, Animesh.
Yes, yeah. Yeah, thank you for your comment.
Any other comments? At the moment, we will have one other opportunity at the very end, but it will be brief because of my lecture. Any other comments at this point?
Sorry, I missed that. Could you say it again, please?
Okay, so I know that people are getting tired, even I am tired. So concluding remarks. Just let me go here. So let me start by highlighting what I said earlier. Haps is or can be thought of as an evolutionary construct, yet it is disruptive, or it has the disruptive potential, and I believe it will be. It is a bit of overlooked because of the next bullet here. Historic view attaches Haps as a non-orbiting satellite to the aerospace and satellite industry. I want to see this as the next layer of macro base station, part of the access network and the 3GPP network. Integration is very important, whether it is Haps and terrestrial or Haps and satellites, the dynamics are different, or integrating all the three. And as we move from this decade to next decade, the next level in my mind is from super macro base station to, after super, the adjective I know is hyper macro base station in 2040s. These will be even bigger, heavier, more energy hungry. But by the way, cooling might be efficient in those altitudes where temperatures are low. But I'm thinking of a structure even bigger than a Zeppelin, but like an International Space Station, a Boeing 747 or a soccer field, with lots of functionalities, as this view graph shows. It is very crowded. But if we consider this as a mega city like Istanbul or Tehran, in the skies, even one Habs will not be enough. I have a cluster of Habs, and they are tied to each other with FSO links, super fast, several terabits per second perhaps. And then these yellow blocks are the data center, caching, edge computation functionalities, and so on. So we have a distributed data center and caching and mobile edge computing. Also, they have big antenna architectures Animesh was referring to. So we have a distributed massive MIMO between them. I can create opportunistically pencil beam beams, but for temporarily, not fixed. Because if somewhere I need, if there is a bus stop here, always crowded, it's not a good idea to cover it through Habs, because you should put a terrestrial base station, a small base station. Here, this link is extremely expensive, extremely valuable. I can only afford using it for unpredictable traffic surges, and pricing might complement. There are aerial highways, cargo drones, as you see. There is backhauling of small cells, and air interface. It might be 5G, 6G, or 7G, because the way we are talking about 6G now, 10 years down the road, we will be talking about 7G. And this is actually 2040's concept. That is pretty much the end. And lots of material on my website, first and foremost, the papers. And then actually at the website, all these papers, journal papers under review, at least a dozen and a half different aspects of aerial networks, and then 2021 papers, journal papers, 2020 journal papers, 2019 and earlier, and also conference papers. We submitted at least 4 to ICC yesterday, just on aerial networks. And then, yeah, all of them are available. So that is it. Let us dedicate 10 minutes for discussion, and we will take it from there. Yes, comments, if there are any. We already had a very rich discussion, but if anything not covered or any novel ideas, I would be more than happy to hear. Mohammed Hoshol, for instance, is generally very vocal. Is he here today with us? Oh, yes, I see Mohammed. So I am looking forward to neat ideas. If you have any neat ideas, feel free to fire.
Yes, Professor, this is Sahabul. Actually, it's about the discussion on cell-free massive MIMO. And actually, on the first slides when I sent it to you, that time I also talked about like cell-free massive MIMO in terms of like distributed massive MIMO. Because when you talk about Haps, and since the channels from Haps to ground stations are like correlated, so just to increase the capacity, we just talked about the cell-free massive MIMO, just to increase the capacity from Haps to ground users.
I am very happy to hear and remember that conversation, Sahabul, since I am in touch with dozens of people on topics related to this. I'm having difficulty in keeping track. I'm happy to hear that. I also encourage you to look into this further, either in collaboration with others or independently. Actually, each of these topics, like take MIMO. If anyone works on MIMO, it doesn't mean that we should all together collaboratively work on MIMO. MIMO has 100 different angles, and it is not accidental that the literature of MIMO is extremely rich, right? It is an extremely broad area. So each of these sub areas, whether it is pilot contamination and edge computing functionalities, there is room for multiple substreams within the group. So in a way, it might be even better not to talk to each other and independently work. For instance, on NOMA or on RSS, no, sorry, not RSS, on rate splitting. We have a number of research going on in the group and with the collaborators. And in order to prevent cross-fertilization, I don't talk to each other person who lead different streams. For instance, one of them is led by Omid, and one of our industrial partners is filing a patent on that technology. So basically, these are extremely rich domains. I welcome multiple people working independently in these areas. Thank you, Sahabul.
Thank you, Professor.
Any other comment, remark? You can write me if you wish. I was hoping that Safwan would say a couple of things. Safwan, do you want to very quickly summarize your research on reconfigurable smart surfaces in just 2-3 minutes, what you are doing currently?
Yes, hello everyone. I'm just maybe you can describe the magazine. Usually people, when they studied recently the smart surfaces, they discussed that in terms of the terrestrial networks, that as a support for the terrestrial networks. However, the performance that people have shown in the literature about this smart surface is based on the size of the area of the RSS. When we move these smart surfaces to the area platforms, we will get two benefits. Actually, the path loss and also the size, especially for large platforms. The large platform like Habs, for example. And recently, just there are few works that try to put the smart surface with the area platforms, like our works, and also there is a work by Professor Gonish about using that in LEO satellites as interlinks between LEO satellites. So I am currently working to analyze the link budget regarding using these smart surfaces with different types of aerial platforms, and also compare that to terrestrial network, and also to study the other effects that could affect the performance of these smart surfaces when we are trying to use it with the area platforms in terms of the weather and other effect. So this is basically what we are doing in general.
Thank you, Safwan. So at the interest of time, maybe I will take one final question or comment if there is any.
Hello, Professor Halim.
Yes, Tasneem.
This is Tasneem. Actually, my question is related to Safwan work, I think. It's my question, how can the intelligent device communication, especially if these devices are flying devices? They are not terrestrial devices.
Tasneem, the link was interrupted. Can you repeat, please?
Yeah, my question is about intelligent surfaces on Habs. How can we use them to support device-to-device communication if these devices are flying devices?
Yes, that's a good question. There is a for example, people, when they are trying to study the channel models, they account for the performance for this mobility effect. For example, I remember one of the works when they study the connections between LEO satellites, they model that mobility like a relay fading, because this mobility caused some drawbacks in the link budget. So maybe this is an issue that we can, I think, to modify the channel models to account for these effects. And also, from the smart surfaces, also we can control the beam in terms of make it larger or thinner. So that's could help, I think, in tackling the mobility issues. This is like a general answer.
Thank you, Safwan. Actually, now I will have to go very soon because of my teaching. But I would like to very quickly say, or if people can, I will introduce people actually very quickly. It is our community. Those of you who can turn on the camera can turn, otherwise it's okay if the camera is off. But I'll go in the order, the way I see you in my screen. Hongchao Zheng is a PhD student with me. Caner Göztepe. Caner, do you want to say a word or two about yourself?
Hi.
Okay, Caner, that was a short. It was a short hi, but.
Oh, Hocam, maybe I can tell on Caner's behalf. We have been working on software-defined radio nodes with Caner, and currently working on machine learning integration in the SDR sets.
A PhD student, right, Güneş?
Yes, he's a PhD student.
Okay, Caner, thank you. Omid Abbasi is a postdoctoral fellow in my group. Muhammed Kadir Hoshholk Muhammad is a postdoctoral fellow as well. Ahmed Ibrahim is also a postdoctoral fellow in my group. Next column, I see Güneş and Tolga Hoca from Istanbul Technical University. Hello, hello to both of you. And Tolga Hoca is with computer engineering department. And Nesrin is a PhD student. Shishi is a visiting PhD student. Amin is a PhD student. Oh, now the order has changed, I guess. Mohammed Hoseyan is a PhD student. Jean Daniel is a postdoctoral fellow. Aizas Chowdhury is a senior research associate. I see next Ozan Alp. Ozan, do you want to say hello and introduce yourself?
Hi, Hadim Hocam, of course. My name is Ozan. I'm working with Professor Güneş in Istanbul Technical University. I'm a PhD student and mostly work on physical layer security topics.
Very good. Very fortunate students working with Güneş Hoca. Then I see İrem Cumalı. İrem, do you want to also introduce yourself? Yes, İrem.
I can. No, this is Berna. Sorry, maybe İrem has a problem with her microphone. So she's my PhD student. Work on the millimeter wave and start work on Haps and NOMA techniques.
Very good, Berna, and I guess you are the next on my screen. Berna Özbek Hoca is a professor in İzmir Yüksek Teknoloji Institute. Is that the right name?
Yeah, that's the İzmir Institute of Technology, or İzmir
that's right.
Technology.
Yes, yes, I knew that I made a small error there. And next on my screen, Tesnim Dervish, who is a postdoctoral fellow as well. Then I'm going quickly, Tesnim, but you waved, I have to wave back. And Safwan is a PhD student. Then I have Kürşat TechBig from Istanbul Technical University as well. Kürşat, do you want to introduce yourself? You are on
Yes,
mute, yes.
I am Kürşat Tekbik from Istanbul Technical University. I am PhD student. My supervisor is Professor Güneş Kurt. I am working on, especially on terahertz wireless communications and smart surfaces.
Wow, all the interesting topics combined. Very good, Kürşat. Then I see Zichao. Zichao is a new student who will formally join us in January. And then Animesh Yadav. Animesh is a postdoctoral fellow as well in the group, or actually titles really doesn't matter formally, I guess, senior research associate. Then Dr. Sahabul Alam, a postdoctoral fellow as well. Next, I see Yin. Yin, I don't know actually who the person is, but can you please introduce yourself?
Oh, hi, I used to work with Gunis, and yeah, he suggested I join your talk. I work in data communication and security, and so I'm looking to see what I can contribute and participate. So I actually, I was looking in your directory, looking for things like security, and I didn't find any. If you have any, could you post it, please? Thanks.
You know, that security work is in progress. I don't have anything that I could post, Yin, but very happy to be connected with you.
Okay, thank you.
Hocam, I should mention Tengi is I invited Tengi especially because she's an expert on security and both in the product level and the research level. And now she's looking towards her PhD options. And I am a big promoter of security in HetNet, so I kept bugging her to about this topic.
Very good. We all need security, Güneş. Good work. Next, I see very fresh PhD, Dr. Yassine Hamamouche from Tunisia and France. Yassine defended his thesis 2 weeks ago. Hello, Yassine. And then I see next Olfa bin Yahya. Olfa, do you want to introduce yourself?
Hi, everyone. This is Olfa bin Yahya from Tunisia. I'm working with Güneş Hoca and Aylem Hoja. We are working on physical layer security for satellite communication.
Thank you, Olfa. Now my screen got all messed up and I can't keep track anymore, but I think I didn't mention Dr. Mohammed Yunus Abdel Sadek, who is a postdoctoral fellow. I think Dr. Aizaz Chowdhury, I guess I mentioned you, sorry for that. Nesreen is a PhD student, Nesreen Sharif. Shi Ren is a visiting PhD student. And I think the last person is Chen Jin Yan. Chen Jin is a PhD student at the University of Ottawa. Did I miss anyone? Probably I did. Okay, well, very nice discussion. I think it is almost 2 hours and 45 minutes. Thank you for staying that long. I am stopping recording right now.